In the vastness of space, an invisible race for technological supremacy is unfolding. Every day, satellites circle our planet like silent sentinels, collecting data, guiding navigation, and keeping the world connected. But as global powers extend their reach beyond Earth's atmosphere, space is becoming a contested domain, one where resilience, autonomy, and intelligence are key. Enter Autosat, an ambitious project by the U.S. Navy that could reshape the future of satellite operations. This fully autonomous spacecraft promises to detect, characterize, and track objects in space without any direct human control, paving the way for an era in which satellites think and act on their own. In a quiet suburb of Northern Virginia, defense and industry leaders gathered for the Potomac Officers Club's Research and Development Summit. It was here that Stephen Meyer, Director of Space Technology at the Naval Research Laboratory, shared a glimpse into a bold new world of space technology. Standing before a captivated audience, Meyer revealed details about Autosat, the Navy's newest foray into satellite autonomy. "We've done a demo of this and proven out the principles. Now we're looking for the next step. We want to get funding to actually build a system along these lines and launch it. That next step, according to Meyer, is to create a new class of satellites that can function independently, recognizing and responding to potential threats or missions without waiting for input from Earth. With the battle for space dominance heating up, such a capability could be a game changer for U.S. military operations. The Autosat Vision, for generations, satellites have relied on human operators and ground stations. In mission control rooms worldwide, teams of experts meticulously monitor telemetry, plan maneuvers, and upload instructions. But in a future marked by advanced cyber threats, jamming tactics, and limited communication windows, manually controlling every aspect of a satellite's journey becomes risky, potentially even impossible. This is where Autosat comes in. Designed to operate without GPS, ground control stations, or human intervention, Autosat's autonomy grants it an extraordinary edge. By leveraging artificial intelligence and machine learning, it can make decisions on the fly, recalibrate its instruments, and even share information with other satellites in a constellation. Inside the technology, at the heart of Autosat's capabilities lies a powerful imaging payload. This advanced system is trained on a vast database of images: airports, roads, runways, buildings, and more. By comparing its own observations to this database, Autosat can spot patterns, track objects, and recognize anomalies with striking precision. Much like a child learning by seeing the world around them, Autosat's AI refines itself over time. With each new piece of data captured, its understanding grows, allowing it to detect unusual or important objects, whether that's an unidentified satellite in orbit or a potential threat on Earth's surface. Stephen Meyer, Autosat's autonomy allows it to operate in isolation, even in denied environments where traditional communications and navigation tools are disrupted. In other words, even if enemies jam its signals or launch cyber attacks, Autosat can continue functioning, watching, learning, and reacting as events unfold. The strategic imperative. Why does the U.S. military need this level of autonomy? The answer lies in the modern threat landscape. Earth's orbit is becoming increasingly cluttered, with thousands of satellites, commercial, civilian, and military, vying for space. Meanwhile, nations around the world are developing anti-satellite weapons and other technologies aimed at crippling orbital assets. Organizations like the U.S. Space Force and U.S. Space Command face the daunting task of monitoring and protecting these orbits. Traditional satellites demand near-constant oversight. Operators plan maneuvers, process data, and check navigation. But an autonomous craft can bypass many of these steps and respond to threats in real time. This could be the difference between a secure orbital fleet and one that falls victim to malicious interference. A constellation of Autosats. Stephen Meyer envisions a future in which multiple Autosat-like satellites work together, forming an interconnected web of resilient assets in space. They would share data, cross-reference each other's findings, and provide overlapping coverage. If one satellite encounters a problem or loses some functionality, the rest of the network can pick up the slack. This concept isn't just about a single, revolutionary spacecraft. It's about building a system that can adapt and survive in high-risk environments. For the U.S. Navy and the broader Department of Defense, this type of architecture could reduce vulnerabilities and offer unmatched situational awareness, aligning with the Space Force vision. While the Navy is advancing Autosat, the project parallels the U.S. Space Force's efforts to weave autonomy and AI into military operations. In August, the Space Force's former top acquisition official, Frank Calvelli, underscored the coming transformation. Frank Calvelli, satellites will become significantly more autonomous in the next 10 to 15 years. He highlighted how future spacecraft will rely less on ground stations and antennas, targets that can be easily jammed or attacked. By removing the human factor and limiting ground-based dependencies, these satellites can make lightning-fast decisions, adjust orbits, and execute defensive maneuvers. The Space Force has already placed its bets on autonomous tech, awarding a contract to Colorado-based Advanced Space for a feasibility study on using AI to guide satellites around orbital threats. The Space Development Agency, SDA, tasked with launching hundreds of small satellites, sees automation as central to a resilient, cost-effective architecture. Revolutionary ground control. On the ground, agencies are revising how they command and control satellites. The Space Rapid Capabilities Office, Space RCO, is modernizing its systems through projects like Rapid Resilient Command and Control, known as R2C2. Directed by Kelly Hammett, the Space RCO aims to make mission planning almost instantaneous. You can run a variety of cases and situations, decide the one you want, and then press the button. When satellites like Autosat are paired with advanced ground systems, they create a seamless loop of decision-making. The spacecraft autonomously gather and interpret data, while automated command and control tools let human operators intervene only when necessary. This synergy saves time, reduces human error, and ensures rapid responses to a fast-evolving battlespace. Challenges on the horizon. As groundbreaking as Autosat may be, significant challenges lie ahead. Developing AI and machine learning algorithms that can handle the stresses of space, radiation, temperature extremes, and power constraints is a monumental task. Testing and validating these systems on Earth can only approximate the real conditions in orbit. Securing the funding for a full-scale Autosat prototype is the Navy's immediate hurdle. Building and launching such a satellite requires sizable resources, and comprehensive testing is crucial before a system is entrusted with critical missions. Once the spacecraft is operational, it must prove it can outperform traditional satellites and do so reliably in the face of threats. Then there are ethical and policy considerations. Autonomy implies a satellite could act without explicit human commands. Commanders and decision-makers must be confident the satellite's AI will operate in accordance with military objectives and legal boundaries. In scenarios with potential lethal implications, like evading or neutralizing an adversary spacecraft, ensuring compliance with the laws of armed conflict becomes paramount. The road to tomorrow. Stephen Meyer, it's not just about building smarter satellites. It's about rethinking how we operate in space and preparing for the challenges of tomorrow. Meyer's words reflect the broad vision behind Autosat. This is more than a single technological marvel. It's a blueprint for transforming how space missions are conceived, executed, and defended. If successful, Autosat could usher in an era where satellites don't just relay data, they interpret it, respond to it, and even anticipate what comes next. Implications for the future. In the coming decades, satellites may no longer be passive tools operated from mission control. They'll be active, intelligent agents in Earth's orbit, capable of defending themselves, coordinating with allies, and relaying crucial intelligence in near real time. For the U.S. military, this shift represents a significant stride toward maintaining dominance in a realm that grows more vital every day. But these developments carry far-reaching impact beyond defense. Autonomous satellites could help with disaster relief by quickly identifying areas of need after hurricanes or earthquakes. They might track environmental changes, monitor illegal fishing, or survey crop health, tasks once limited by sporadic connectivity and ground operator workload. By automating data collection and analysis, these systems have the potential to offer benefits to civilians and governments alike. Still, the impetus behind Autosat remains clear. In an era of escalating competition and mounting threats in space, the U.S. must safeguard its orbital interests. Maintaining a technological edge is not merely a goal, it's a strategic necessity. Moving forward, the road ahead for Autosat will be challenging. Securing funding, crafting a prototype, and proving its mettle on orbit. Yet the Navy's pursuit of fully autonomous satellites has already sparked a new wave of thought across the Department of Defense. Between the Navy's Autosat, the Space Force's AI initiatives, and other programs championing resilient architectures, a paradigm shift in space operations is now underway. Whether it's defending against emerging threats, speeding up decision-making, or reimagining the very nature of satellite operations, autonomy has become the watchword of 21st century space. In the silent vacuum above, Autosat and its successors may soon redefine what it means to watch over our planet and the myriad challenges that lie beyond. This is more than the next leap in military technology. It's the dawn of a new era in how humanity relates to the space we inhabit. The future, it seems, belongs to those who can adapt first. And with Autosat, the U.S. Navy aims to ensure it remains at the cutting edge of that exciting new frontier. If you enjoyed this exploration, like, subscribe, and share to stay current on emerging defense technologies and strategic developments. Until next time, stay safe, stay informed.